Throughout the year, we're going to have to make sure that we are able to rearrange equations, specifically these linear equations, by solving for y. This is going to be a really important skill for what's coming up when we start graphing lines. We want to be able to get our equations in slope-intercept form, meaning we solve for y. So here's my thinking. I find my y term, or any terms that have y in them, and I want those terms to be by themselves on that side of the equal sign. So find any terms that don't have y and get those moved to the other side. So, for example, I have a positive 9x, so what I'll do is subtract 9x from both sides to get that moved over. And you don't necessarily need to show all these steps, but I'll do that for this first example. When you subtract 9x from both sides, don't forget it's a negative 4y that's left over. That subtraction sign will come down as a negative. And then I don't have like terms on the other side, so best I can do is just say negative 9x and then a plus 7 because it was positive. Now that doesn't mean that y is solved for yet. I'm not done. I want my equation, remember, to say y equals. But now that I have that y term all alone, now what I can do is get rid of that negative 4. Since it's negative 4 being multiplied by y, I'm going to do the opposite and divide by negative 4. And what I like to do is divide each individual piece. Again, knowing what's coming up with slope-intercept form, this will be probably your best bet. Negative 4 divided by negative 4 is just 1, or just 1y, which is what I wanted. And then I go through and I simplify each of these other fractions individually if I can. Negative 9 over negative 4 can technically be simplified. I can cancel out the double negatives and just have 9/4. I like to put the x on the side, although you could also have the x on the top. Positive 7 divided by negative 4. I just am going to put minus 7 over 4. If you want to put plus negative 7 over 4, that's fine. But there's my rearranged equation for y. Let me go ahead and just do the second one for you. If you want to try it on your own, you can pause right now. Otherwise, I'm just going to proceed with this problem. My first step again, find my y terms and get those isolated. So any terms that don't have a y in them, get those moved to the other side of the equal sign first. You can also think of these as any time you cross the equal sign, you would change signs. Rather than subtracting 2x, which I'm technically doing in my head, I just like to think of it as I'm changing sides, so I'm going to change signs. So negative 2x, and that 14 didn't move, so I have a plus 14. That's a positive 14. Y is not solved for. There's still a number in front of y, and that's a negative 1 if you want to write that in there. So to finish this, I'm going to divide everything by negative 1, or again, the trick is just go through and change all your signs, in this case by dividing by negative 1. So I'll have a positive y equals a positive 2x, and then a negative 14. And so there's my rearranged equation with y being solved for. And I'll do something very, very similar for when I'm trying to solve any kind of formula, whether it's a geometric formula like this perimeter or something from science. If I want to rearrange it, I can use a very similar method to what we just did. So in this case, I want to solve for w, meaning I want a new equation that says w equals instead of p equals. So find your terms that have w in them, and you want to get those isolated first. So any terms that don't have a w in them, get those moved away from the side that that's on. So I'm going to take this 2l, and again, subtract that from both sides, or just think I'm moving across the equal sign, so I'm changing signs. So that p is not changing sides, it's still a positive p. Minus 2 times l is then equal to 2w. Once that's been isolated, I'm going to go ahead and divide everything by 2. If you want to do this, the entire side divided by 2, that's not wrong to do it that way. I just don't like doing it that way. Some people make mistakes when they go to simplify. It's not wrong. If you want to do that, fine. But what I'm going to do instead is what I showed you up top. I'm going to divide each individual piece of this problem by 2. So those 2's will cross out. I'm going to sort of rewrite the order of my equation too, so the w equals is in front. P divided by 2, there's nothing I can do with that. It's just p divided by 2. What I like to do though is I'm going to put 1/2 times p. It's the same thing as p divided by 2 if you want to think of it that way. For that l term, those two 2's will cross out, so I just have a minus l. There's my rearranged equation. It's the same equation, just rearranged, so now it says w equals. And then they've gone and asked me to do one more thing here at the bottom. They say, go ahead and use your formula, find the width of a rectangle that has a perimeter of 41 centimeters and a length of 5 centimeters. So they're just basically saying plug these values in and find a new width. So I'll have w equals 1/2 times the perimeter is 1/2 times 41. And then according to my equation, I'm going to subtract 5 from that. When I do the work on that, I end up with a final width of 15.5, and then include a label. It looks like we're in centimeters, so a width of 15.5 centimeters. Now I ask people a lot, like, did we have to use that rearranged equation to find w, or could we have plugged these values into the original problem and still came up with the same answer? And people usually realize pretty quickly we didn't have to rearrange it. but sometimes it's nice too. It made it a little bit easier, possibly, but no, it wasn't necessary to use the rearrange to find the final answer. But I do want to make sure we have that skill, that ability to rearrange the equation, get the new rearranged equation.